Look at the modern digital office. It operates in a state of high entropy, a chaotic, swirling storm of emails, chat messages, and notifications bouncing between isolated applications without any inherent structure. When you use legacy software, like standard chat apps or relational databases, the system only saves the final document or the last message in a thread. It records what was decided, but it discards the journey of how that decision was made. This network of data points represents a project. The connecting lines, representing the arguments, compromises, and human intent, instantly dissolve. The semantic context vanishes into deleted chat logs, leaving behind isolated, floating nodes. When we feed those disconnected nodes into an artificial intelligence, the system struggles. Because legacy platforms only store the aftermath of a project, any AI integrated into them is functionally blind to the reality of the work. To unlock actual machine autonomy, organizations have to stop merely recording results. They need to capture the dynamic context of how work is actually executed. The Topics platform operates on a strict structural law. Humans, AI agents, and projects are all mathematically treated as identical entities called context containers, sharing the exact same weight in the system. For biological and artificial workers to collaborate as true peers, they require the exact same native access to the digital workplace. The system achieves this equality using the Model Context Protocol, or MCP. MCP is an open standard that allows AI models to securely connect to external tools and data sources. This bridge gives AI agents their own dedicated workspace accounts, allowing them to pull raw data directly from HR platforms or CRM databases. Let's look at a practical trigger within the platform, known as a domain event. This is a specific condition, like a calendar date or a data update, that forces the system to initiate a task. Imagine a marketing director triggers a mandate to launch a new corporate campaign. Immediately, a human strategist, an AI copywriter, and an AI compliance officer are all pulled into the same shared project container. They now occupy the same workspace, looking at the same data. By giving humans and AI identical structural containers and data access, the platform creates a shared reality where machine input is treated with the same weight as human strategy. This collaboration is a dynamic collision. Inside this collision, a dialectical debate unfolds. The AI copywriter pushes for creative phrasing, the compliance agent tests the text against legal constraints, and the human strategist injects business intent. This creates a unique mathematical problem. In a symmetrical system where humans and machines debate over the correct approach, how does the underlying architecture objectively decide whose context is correct? The platform uses the Shapley value. The Shapley value is a mathematical formula from cooperative game theory used to calculate the exact marginal contribution of each participant in a group. The system uses it to weigh the stake of every agent in real time, adjusting their physical influence based on the strength of their data. Notice how the equation resolves. The system extracts the mathematically heaviest components from all three nodes to forge a single block of consensus. The outcome is determined by semantic utility, rather than defaulting to the loudest voice. This mathematical arbitration ensures that every enterprise decision is grounded in a weighted consensus of the highest quality data available. In the microsecond that the debate reaches mathematical consensus, topic time occurs. Abstract context instantly freezes into perfectly structured, executable content. This crystallized block slots into a vertical timeline. Unlike legacy databases that overwrite files, the entire collision, chain of thought, Shapley math, and final decision is written to an immutable ledger. The ledger expands downwards, with deep vector roots locking the why underneath the what. This structure creates total forensic accountability. If a strategy fails 6 months later, auditors or new hires can rewind the ledger, trace the roots, and identify the exact data point that influenced the historical decision. The ledger serves as a mathematically verifiable memory bank, preserving the company's entire cognitive history as a series of active, traceable events. Now zoom out and imagine an entire organization operating on this ledger format over a span of months and years. As you can see, hundreds of individual timelines weave together. The continuous accumulation of these mathematically validated collisions builds an immense physical geometry of operational knowledge across the company. Because the history is pristine and fully contextualized, a newly deployed digital colleague can learn to execute Coderex tasks by mathematically querying the historical ledger. Using this architecture, the system moves past the friction of manual data management and passive storage. Work is now a continuous ecosystem. Human strategy and machine execution fluidly collide, debate, and collaborate in systemic symmetry. By capturing the physics of collaboration, the Topics platform gives birth to the Agentic Enterprise, a mathematically balanced orchestration of human and artificial intelligence.